Hello everybody, I am Basil Sami and this is our first Friday video from our channel Amazing Chemistry. In every Friday we're going to talk about explanation of a book called Modern Analytical Chemistry by the author David Harvey from DePauw University. In chapter 1 we are going to define analytical chemistry, discuss the analytical procedure and know some scientific terms that every chemist should know. So, what is analytical chemistry? Defining analytical chemistry in such a sentence is very difficult because we should define analytical chemistry in books of 1000 pages. But why? Analytical chemistry is not a such a branch of science or branch of chemistry, but it also an application in any other branches like physical chemistry, organic or inorganic chemistry. But we can define it in a small sentence which it can include 70 to 80% of the real analytical chemistry, which is analytical chemistry is a science which deal with analyzing of any chemical substance qualitatively or what is present that it means that what is this chemical substance or quantitatively which means that the concentration of this chemical substance and improving established methods or developing a new test method and the validation of these test methods. The previous definition is not including the routine analysis of any chemical substance because the routine analysis of any chemical substance called chemical analysis, not analytical chemistry. Analytical chemistry include only analyzing of chemical substance qualitatively and quantitatively and developing and the validation of any system method. While the routine analysis called chemical analysis. How to make an analytical procedure or how to develop a new test method for any chemical substance. We should first know the chemical properties and the physical properties and the chemical structure of this chemical substance, which is mean identifying and defining the problem. Secondly, we should design an experimental procedure or see what is the best analytical procedure or the analytical instrument that will analyze accurately this chemical substance. Thirdly, we will try this test method or this experimental procedure by a real experiment to see if it's accurate to analyze this matter qualitatively and quantitatively or not. And you will gather the data to compute it to see the accuracy of this test method. Finally, you will propose if this test method is really accurate and efficient to analyze this chemical substance or not. We have an example here to develop a gravimetric test method for sodium chloride in 4 gram sample containing calcium chloride and sodium chloride. To make a gravimetric test method for any chemical substance, you should know what is its mass and divide it by the total mass of any sample and multiply it with 100 to get its concentration by percent. So that's our equation. Concentration of sodium chloride by percent will be equal the mass of sodium chloride over the total mass of the sample multiplied by 100. The question is, what is the best instrument to analyze or determine the mass of any chemical substance? Of course, it will be the analytical balance. But we have got a problem here. You can't measure the mass of the sodium chloride on the analytical balance because it's already mixed with calcium chloride. So we should first find a best separation method to separate the calcium chloride and sodium chloride. You can pause the video for 1 minute and think about the best method to separate calcium chloride and sodium chloride and add this solution in the comments to discuss it. But now I will tell you my solution for this. If you want to separate calcium chloride from sodium chloride, you should first, as we mentioned before, see what is the chemical properties of the calcium chloride and the chemical properties of sodium chloride. You can separate each other. You can separate them by precipitation. That you will precipitate one of them, and make the other already dissolved. Then precipitate then separate the precipitate from the total solution. In this, I will put or I will add sulfuric acid on the solution of the sample. So the calcium chloride will be converted to calcium sulfate and will form a precipitate, and I will filtrate the solution and throughout the precipitate, and I will take the solution and evaporate the solvent, which it will be water, and the excess of the sulfuric acid and after the evaporation I will dry the formed solid, which it will be of course the sodium chloride, and I will measure it on the analytical balance to get its mass. If you're gonna to say that the mass by example, it will be the obtained mass of the sodium chloride after this separation method, it will be 2 gram. So we will take this equation down there, and it will be the mass of the sodium chloride will equal the mass of the sodium chloride, which is 2 gram, over the total mass of the sample, which is 4, multiplied by 100, which it will be equal 50%. So if you're gonna to repeat the procedure, first we should identify and define the problem. Our problem here, it will be that we wanted to separate the sodium chloride from calcium chloride to measure the mass of sodium chloride by itself, then we divide its mass by the total mass of the sample. So that's our problem, to separate sodium chloride from calcium chloride. Secondly, we wanted to design the best separation method to separate sodium chloride from calcium chloride, and that doesn't will not happen unless we study the chemical properties of the calcium and the sodium chloride. Here, when we study the properties of both of them, we will find that the sodium metal or the sodium ion was related to group 1A, and the calcium is related to group 2A. We all know that group 1A, or the metals of group 1A, when it form salts, their salts is not precipitated but all are ionized and dissolved in water. While calcium group, or the group of 2A, all of its salts or all of its metal, they form a precipitated as specific salts like sulfates and carbonates. So in this So that's led us to the third step, which you will indicate, which we will say in it. We will put sulfuric acid to the sample, so we will have calcium sulfate, which will be precipitated. Number four, we will I'm sorry, we will filtrate the solution from the precipitate. We will get a funnel here, and we will get a filter paper, and we will have our beaker to pour all the sample solution in it. So we will get the filtrate solution down there, and we will get the precipitate up there. We will throw out the precipitate because we don't know, need it. It was a calcium sulfate, which we don't need it for anything. We only need the sodium chloride. But now we have the problem that the sodium chloride is dissolved in water. So we need to put this flask in an oven to evaporate the water, so we will get the solid sodium chloride. And we will take this sodium chloride and put it on an analytical balance to take its mass or to measure its mass, which it will be by example at 2 gram. Then we will calculate this mass over the total mass on a normal calculator on a computer system. And that will be a small example to how to make a test method for any substance. We will found here the measuring test method is not hard, but the separation of the sample treatment is very hard. You will find that another situations or another problems, you will find the opposite of it. You will find that sample pre-treatment is very easy while the measuring is very hard. And you will sometimes you will find that both of them is very easy or both of them is very hard. And that we will discuss in another chapters. Now, finally, we have to know some scientific terms that every chemist should know. What is qualitative analysis? Qualitative analysis, it was an analysis in which we determine the identity of the constituent or the chemical substance species in the sample. We want to know only what is in this sample. We don't know to know what is the concentration of it. While the quantitative, we want to know what is the concentration. We want to know what is it and what is its concentration. Characterization, it was in its name resembles the qualitative, but it is totally different from it. Because in characterization analysis, we want to evaluate the sample chemical or physical properties. We want to know the chemical properties of the sample, of the whole sample. So if the sample is a mixture of more than one component, we will find that the chemical properties of it is different from each component individually. So characterization is different from qualitative, not resemble it by its name. And finally, the fundamental analysis. Fundamental analysis, it was a purpose to improve the analytical method capabilities, which it will be resemble the validation of test method. That if you want to know the efficiency of any test method, you make a validation of it, which is a testing the analytical test method and testing its accuracy to measure the analyte you want to measure. Finally, we finished this chapter. This is chapter 1, and this is a summary of it. We will discuss in next Friday chapter 2. Don't forget to like, share this video, and follow our page. See you soon.